Hi everybody. In this section we're going to talk about inverse functions and just functions in general, and we're also going to talk about inverse sine, inverse cosine, and inverse tangent. And then we'll pick up the remaining three inverse functions, the cosecant, the secant, and the cotangent, and we'll talk about how to evaluate these inverse function values with exact values and on the calculator. Alright, first let's just talk about functions. In a function, each x value can produce only one y value. You should remember that from algebra. That's what makes a function, if each x can only match one y. Now the inverse of a function reverses the input and the output so that the function runs backwards. So here I've got two functions set up. The first one is f, and the second one looks like f to the negative 1, but this is really f inverse. You do not pronounce this like an exponent. You say f inverse of x. So now watch what happens. If f is a function, then I'm going to feed it a number, and it's going to spit out an answer. So this function, if I feed it a 1, it spits out a 3. If I feed it a 2, it spits out a 6. Now you can probably guess what the function is, but it really doesn't matter. You just need to know that when I give it a 1, it gives me a 3. Okay, now the inverse function works backwards from that. If I feed the inverse function a 3, it has to spit out a 1. See, it just reverses the effects of f. If I feed it a 6, it's going to reverse the effect of f. It's going to spit out a 2. That's what inverse functions do. They reverse the input and the output. Now make sure you understand that when you see f inverse, that you know that this negative 1 is not an exponent. This is not f to the negative 1. This is not the reciprocal of f, because this is not an exponent. This is read f inverse. So make sure you understand the difference between the exponent and the inverse notation. Okay, now a little more information about inverse functions. In an inverse function, each x value can still only produce one y value. So yes, it's running backwards from the original function, but it still has to follow the rules of functions. So what this means is that the original function has to work both ways. Each x value can only produce one y value, but also each y value can only produce one x value, or can only match one x value. This is so that when you reverse the input and the output, the reverse is still a function. Okay, so if you don't have that, then your inverse relationship is not really a function. Now that shows you the problem with the sine function. The problem is that each y value matches an infinite number of x values. See, you'll remember if you think about the graph of the sine wave, you know that the sine of 0 is 0, the sine of pi is 0, the sine of 2 pi is 0, the sine of 3 pi is 0, 4 pi, 5 pi. Okay, we have all of these different x values producing the same y value. That does not keep sine from being a function, but it is going to keep sine inverse from being a function, because when you reverse this, this is now the input, and this one input is matching all these different outputs when you go to sine inverse. So in order to make sine inverse into a function, we limit its range. We will only allow sine inverse to give us angles that are between negative pi over 2 and positive pi over 2. So that way, every sine value only occurs once. See, you remember the sine is the vertical coordinate. So here we've got our sine values going from negative 1 to 0 and then up to positive 1, and each one only occurs once. If we completed the circle, we'd have all those sine values occurring again. So that's why we only do the right half of the circle. And we say that we're going from negative 90 degrees to positive 90 degrees. Or in radians, we say negative pi over 2 to positive pi over 2. So this, again, this works because we're going our sine values are going from -1 to +1 only one time. Nothing repeats. Okay, now when you see that you see y equals sine inverse of x, or when you see y equals arc sine of x, this is what you say to yourself. Y is the number, or y is the angle, in the interval from -π/2 to +π/2, whose sine is x. Remember, the y is going to be an angle. The result of an inverse sine is always to tell you the angle. Okay? Now think about what numbers can be plugged in as sine values. The domain is all the numbers that can be plugged in. So what numbers are valid sine values? Well, we know that all sine values have to be between -1 and +1. But now we're saying that when you plug in a sine value between -1 and +1, the angle that you get back has to be between -90 degrees and +90 degrees. So these two are saying the same thing. -π/2 to +π/2 is the same range of angles as -90 to +90. It's just that this is in degrees and this is in radians. Okay, now we'll look at each of these. We'll evaluate these, and we will not need a calculator for this, although you could use the calculator. But I want you to know how to do it without the calculator. So first it says y equals arc sine of 1/2. Probably the easiest thing to do is switch this into regular function form. So if y is the inverse sine of 1/2, that means that the sine of y equals 1/2. Now remember, arc sine or inverse sine is limited. The only angles that we can use are between -90 and +90. So if our only two choices for quadrant are 1 and 4, then what quadrant would have a positive sine? Quadrant 1. So our angle is in quadrant 1. We know from memory that it has a reference angle of 30. So this answer, y equals 30 degrees. Or if you want radians, y equals pi/6. Alright, now part B. Y equals sine inverse of -1. First look at it in sine form. So the sine of y equals -1. You know, an inverse function reverses the input and the output. So when you go back to function form, you switch the input and the output. So now if you think about the coordinate system, where can you have a y value of -1 on the unit circle? That would be at the bottom of the unit circle, which you would normally say 270 degrees, but because we have to give our angles between -90 and +90 degrees, we know that this is going to be -90 degrees. That's the same angle as 270. It's just in the range that we're allowed to have. Okay, part C, y equals sine inverse of -2. We'll switch into regular function form and we'll say the sine of y equals -2. Okay, now think, you know that all sine values have to be between -1 and +1. So how can we have an angle whose sine is -2? And the answer is we can't. That angle does not exist, so this is not possible. Alright, now caution. Be certain that the number given for an inverse function value is in the range of the particular inverse function being considered. So what it's saying here is, if you decide that a certain angle is the answer to your inverse function problem, make sure that that answer is in the range that's allowed for that inverse function. For sine, that allowed range is -90 degrees to +90 degrees. Okay, now let's talk about inverse cosine. When we see y equals cosine inverse of x or y equals arc cosine of x, we're going to say to ourselves, y is the number in the interval from 0 to pi whose cosine is x. Now, why did we have to change interval? You might be thinking, why can't we just use -π/2 to +π/2 for all the inverse functions? Well, the reason is, if you think about these two functions, these two quadrants where inverse sine is allowed to be, both of those have positive cosines. So there's no way to get our negative cosines, no way to plug in our negative cosine values if we use the right half of the coordinate system. But if we let inverse cosine go from 0 to 180 like this, then quadrant 1 will tell us the positive cosine values, and quadrant 2 will give us the negative cosine values. So that's why they have to change the range for inverse cosine. Okay, the domain for inverse cosine is the same as the domain for inverse sine. It's still -1 to +1 because all of our cosine values are still between -1 and +1. But the range has to be changed, like I said, from 0 to pi instead of -pi/2 to +pi/2, because on the right half cosines are all positive, but in the top half we get half positive and half negative. Let's practice a couple of inverse cosine problems together. So we'll do the same thing we did on the inverse sines. We will first switch into regular function form. So if y equals the arc cosine of 1, then we will say the cosine of y equals 1. Okay, now from memory we know that what angle has in between 0 and pi, or 0 and 180, what angle has a cosine value equal to 1? And it would have to be y equals 0. Okay, let's come over here to part B. If y equals cosine inverse of -square root of 2 over 2, we're going to switch that into regular function form. So we would say cosine of y equals -square root of 2 over 2. Remember, just switch the input and the output when you go from inverse function form to function form. Okay, now from memory, what reference angle has a cosine of square root of 2 over 2? And you know it has to be 45. And then, because this is negative, if our choices are quadrant 1 or quadrant 2, like they are for inverse cosine, if this is a negative cosine, you have to choose quadrant 2. So, you know the reference angle is 45. You know the angle is in quadrant 2. So that leaves 135 degrees for y. Or, of course, in radians, this would be 3 pi over 4. Now, inverse tangent is very similar to inverse sine. It's not exactly the same because tangent is undefined at -pi/2 and +pi/2, but we will use the same two quadrants basically. So inverse tangent, the answer will have to be between -90 degrees and +90 degrees, or in radians would say -pi/2 to +pi/2. But I'm using parentheses now to show that the answer won't ever be exactly -pi/2 or exactly pi/2, but the same two quadrants apply. Okay, now secant, because it's the reciprocal of cosine, secant inverse can be treated the same as cosine inverse. That is, they have the same range. Now, of course, they have a different domain. Secant values cannot be between -1 and +1. They have to be outside. They have to be either less than -1 or more than +1, but the range is the same. And cosecant inverse can be treated the same as sine inverse. So, in order to find an inverse secant or an inverse cosecant, this is what I want you to do. Translate your expression out of inverse form. So instead of having it of cosecant inverse of x equals y, write it as cosecant of y equals x. And then do the reciprocal of both sides so that it's no longer cosecant or secant, but now it will say sine or cosine. Then you can either do it from memory or you can change it back to inverse form if you need the calculator and then evaluate it. Here is a chart that kind of summarizes what we've been talking about. Sine inverse, you have to put in an angle or a sine value that's between -1 and +1. You're going to get out an angle that's between -π/2 and +π/2. That means quadrant 1 and quadrant 4. Cosine inverse, you still have to put in something between -1 and +1, but your answer will now be between 0 and pi, and the quadrants that covers are quadrant 1 and quadrant 2. Tangent inverse, well, you know, tangents can be any value, so what you can plug in can be anything, but what comes out as your angle for inverse tangent has to be between -π/2 and +π/2. Can't be on the axis, you know, can't be those quadrant angles, but it's the same quadrants that you had for inverse sine. Okay, now we haven't talked about inverse cosine yet, so skip over that for a minute, but notice how inverse secant, we have the same quadrants for inverse secant as we do for cosine, and we have the same quadrants for inverse cosecant as we do for inverse sine. This has to be written a little different here because secant is not defined for pi/2 and cosecant is not defined for 0, so they had to leave out those values. But otherwise, you know, what's important is that the quadrants are the same, so it's not going to mess you up switching from secant to cosine or cosecant to sine. Okay, now we're going to evaluate a couple of inverse functions together, the new ones that we've picked up. So this first one says theta equals arctangent of 1. Well, the first thing we need to do is look at it in regular function form. So we would say tangent of theta equals 1. All right, now, if your choices for inverse tangent are quadrant 1 and quadrant 4, and you have a positive tangent value, then you know that your answer is going to have to be in quadrant 1. So now we have to think of what is the reference angle. Well, this value from memory we know has a reference angle of 45 degrees, and so that's our answer. Theta equals 45 degrees. And let's look at the second one. Theta equals secant inverse of 2. Well, the first thing I would like to do is get this out of secant inverse form. Let's write it in secant form. So we can say the secant of theta equals 2. Okay, now we don't usually think in terms of secant, so let's do the reciprocal of both sides here. We'll say the reciprocal of secant is cosine, and the reciprocal of 2 is 1/2. And so now we still have the same relationship, it's just in a more familiar form. So we could even switch it back to cosine form if we wanted to, or inverse form rather. We could switch it back to inverse form. So here I've drawn the coordinate system, and our choices for inverse cosine are either quadrant 1 or quadrant 2. This is a positive cosine value, so we know it's going to be quadrant 1. And we know from memory that the reference angle that has a cosine of 1/2 would be 60 degrees, so theta equals 60 degrees. Now, inverse cotangent has a special little twist. Remember, this is the graph for a tangent, and this is the graph for inverse tangent. Okay, tangent branches go from -90 degrees to +90 degrees. That's why it makes it so nice for inverse tangent to go from -90 to +90, because you stay all on the same branch. But for inverse cotangent, -90 to +90 wouldn't be so nice, because the positive ones would be on this branch, but the negative ones would be on a branch over here, totally different branch. So instead of doing that, what we do instead is we have -90 to +90 for inverse tangent, but we have a range of 0 to 180 for inverse cotangent. So basically what this means is that inverse cotangent does not go in quadrant 1 and quadrant 4 like inverse tangent does. Inverse cotangent has to go in quadrant 1 or quadrant 2. Now, if you use inverse tangent to find an inverse cotangent value of a negative number, the calculator, because you're pushing inverse tangent, the calculator is going to give you an answer that's either in quadrant 4 or quadrant 1. But if it was a negative cotangent, it's going to tell you something in quadrant 4, but you need it to be in quadrant 2. So what we're going to do as a fix is just, if you do the inverse cotangent of a negative number, you will add pi, or 180 degrees, depending on which one you need your answer to be, so that your answer will be quadrant 2 instead of quadrant 4. So we'll practice that a little bit. It only ever comes up if you do the inverse cotangent of a negative number. So to find an inverse of a cotangent, translate it out of inverse form. Do the reciprocal of both sides. You'll go from cotangent to tangent. Change back to inverse form if you need to put it in the calculator. Now, if your cotangent number was negative to start with, your answer that you get back is now in quadrant 4. Add 180 degrees to make it in quadrant 2. Or if you need your answer in radians, add pi. Okay, just here are a couple of examples we'll do together. Okay, this first one says find y in radians if y equals the inverse cosecant of -3. Well, the first thing I want to do is translate it out of inverse form. So we're going to say the cosecant of y equals -3. Now we're going to translate it out of cosecant form. We're going to do the reciprocal of both sides, and the reciprocal of cosecant is sine, and the reciprocal of -3 would be -1/3. Now, 1/3 does not match a reference angle that we have memorized, so we'll have to use the calculator to help us with this. So we'll go back to inverse form. We'll say sine inverse of -1/3 equals y. Okay, you just put that in your calculator just like it looks. Make sure your calculator is in radian mode because they asked us to get the answer in radians. And when you do, y equals -0.3398. And I hope that you'll actually try that on your calculator and make sure that that's what you are getting. Okay, part B says find theta in degrees if theta equals arc cotangent of -0.3541. So first of all, change your calculator back to degree mode. And now let's look at our equation. We want to change out of arctangent form and into cotangent form. So let's say cotangent of theta equals -0.3541. Now I want to get out of cotangent form. And so I'll do the reciprocal of both sides. I'll say tangent of theta equals the reciprocal of -0.3541. Okay. Now this is obviously not a tangent value that matches a reference angle we know. So clearly we're going to have to put this in inverse form again to evaluate it. So I'll say tangent inverse of that reciprocal equals theta. And we've already made sure our calculator's in degree mode. And you can enter this just like it is. You can say tangent inverse -0.3541 reciprocal equals, and the angle you get back is -70.5 degrees. But now remember, this was an arc cotangent, so the angle we get back is supposed to be between 0 and 180. But we clearly got back an angle that's between -90 and +90. Why? Because we're using inverse tangent, and the calculator knows to tell us an angle between -90 and +90. We are the only ones who know that this was originally an inverse cotangent problem, so we have to know to add 180 degrees to this to kick it over to the second quadrant, so now it's 109.5. Okay, so one more time. Switch out of arc cotangent mode into cotangent form. Switch out of cotangent form into tangent form by doing the reciprocal of both sides. then back to inverse form so that the calculator will evaluate it for us. Because the calculator thinks that we're doing inverse tangent, it gave us something between negative 90 and positive 90, but we know that it's supposed to be between 0 and 180, so we add 109, or we add 180 to it, and we get 109.5. Now this only comes up when you do the arc cotangent of a negative number. Otherwise, the arc cotangent of a positive number, this does not even come up. Okay, last example together in this section, evaluate each expression without a calculator. This question is asking you, what is the sine of an angle whose tangent is 3 over 2? What is the sine of an angle whose tangent is 3 over 2? Well, we've been working this problem all semester. We keep seeing it in different forms. So first of all, I'm going to draw this angle whose tangent is 3 over 2. Now we know that this is a tangent value and it's positive. So if we're limited to either quadrant 1 or quadrant 4, this tangent must have come from quadrant 1. Okay, now to draw the triangle, we know that this is y over x. So I've labeled my two sides here y over x, and I can find the hypotenuse. I'll say 2 squared plus 3 squared would be 4 plus 9, that's 13. That means the hypotenuse is going to be square root of 13. Okay, now the sine of that angle is going to be 3 over square root of 13, and it needs to be rationalized, so 3 square root of 13 over 13. Now, let's look at this second part, tangent of cosine inverse of negative 5 over 13. So what this is asking you is, find the tangent of an angle whose cosine is negative 5 over 13. So you do the same thing. You draw it on the coordinate system, but let's figure out how to know where it is. Inverse cosine angles have to be between 0 and 180. So this is either quadrant 1 or quadrant 2. Based on the fact that this is a negative cosine value, I now know that it's quadrant 2. So we'll draw our angle in quadrant 2, and we'll draw the little side here. We know cosine definition is x over r, so that must be a 5 and a 13. And we can find the missing side. We say 13 squared minus 5 squared. 169 minus 25 is 144, so this missing side is square root of 144, which is 12. Okay, now I'm looking for the tangent of this angle that we just drew. So tangent is y over x, but it's in the second quadrant. Tangent should be negative. So this tangent is negative 12 over 5. And I had a little writing error there, but I've got it fixed now. So you can see, you know that tangent definition is y over x. So negative 12 over 5.